Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. We're going to look at a question involving solving a differential equation. Now the differential equation we have got here is a first order differential equation, and it's one of the most simple types of differential equations you will come across. Now the keywords in this question we're going to highlight. So we've got to find the particular solution of this differential equation, which is given by dy by dx is equal to x cubed plus 6x. And we're told that x is equal to 2 and y is equal to 20. Now the key facts in this question are we need to know what these keywords mean. So the differential equation is an equation involving dy by dx, and we can get first order and second order differential equations. For A-level maths we will only be dealing with first order differential equations, and they won't even mention that it's a first order differential equation. You will just be told it's a differential equation. If you do further maths you will come across second order differential equations. Now your general solution is your answer. So you've got to find an equation in the form y equals some function of x plus c. And this could be any graph at any different level. It could be any different value of c could be on the end of it. So it could have multiple different answers for this graph. But if you put in your initial conditions, which you can see up here, we get something called the particular solution. And the particular solution is basically the equation y equals f of x without the c value, because you have put in your values of x and y to evaluate this value of c. So we know the value of c using the initial conditions, and the initial conditions or boundary conditions are the initial values of x and y. And in this case here, these are our initial or boundary conditions for x is 2 and y is 20. Now we have got to solve this equation. Now we have got an equation dy by dx is equal to x cubed plus 6x. And we have got to find an equation, we've got to find the particular solution, so we've got to find y equals f of x. So think about how you can get from dy by dx to get to y, what you have to do to this function in order to be able to find the value of y. Then you need to substitute in your x value and your y value, and then once you've done that, you will get the value of c, and then you'll get your equation y equals f of x, and then you've got your answer. Press pause, have a go to see if you can work out the value of y from this differential equation. Press play when you're ready to hear the answer. Well done. Hopefully you've managed to work out the answer of y equals some function in terms of x. So we're going to start off by thinking about this dy by dx. Now dy by dx is the differential of a function. So to go back to y, we have to integrate. So if I integrate dy by dx, I'm going to get 1 y. Then I've got to integrate the right hand side. Now this is how we normally integrate. So dy by dx will integrate to give me y. But if you look at how I've written this out, I've written it out differently to just thinking what is the integral of dy by dx, which is y. We can see here it's going to be y. I've written it in a different way to how we've normally seen it written. And what I've done is I've done something called separating the variables. I've taken this x function here at the bottom and I've multiplied both sides by x. So dy is on its own. I've multiplied this side by dx. So I could treat this left-hand side as a fraction, and I could split this fraction up into dy on the left-hand side and dx on the right-hand side. Then when we do this and we separate it, we have to put an integral sign on the front of both of these stages. Now the integral of 1 is just y with respect to y. The integral of x cubed, add 1 to the power, divide by the new power, is x to the 4 over 4. And then here, plus 6x, the integral of 6x, add 1 to the power, divide by the new power. So 6x squared over 2, 6 divided by 2 gives me 3. Remember to add your plus c on the end, and this is your general solution. So this is this stage here, my general solution. Now you could have gone straight from dy by dx into y equals x to the 4 over 4 plus 3x squared plus c. But by writing it in this stage here, we've done something called separating the variables, which is a really useful skill to be able to integrate later on. and this is what we're looking at here, introducing the concept of separating the variables. So from here, I've got my general solution. Now my particular solution comes from substituting in the value of x is equal to 2 and y is equal to 20. So we're going to substitute these two values in. So instead of writing y, I'm going to write 20. Instead of writing x, I'm going to write 2. And x again, I'm going to write 2. And I'm going to work out what the value of c is. So we can work out the value of 2 to the power 4 over 4 plus 3 times 2 squared, which will give you 4 plus 12 plus c. And if you rearrange by taking 4 from both sides and taking 12 from both sides, you will find that c is equal to 4. So we now know the value of c is 4. So if I substitute that into my general solution here, this becomes my particular solution. Y equals x to the power 4 over 4 plus 3x squared plus 4 is my particular solution. So you can see that we have worked out the general solution, the particular solution, we've met initial conditions or boundary conditions, and we've met the word differential equation. So there's lots of key terminology for this question, which will help you later on when you come to separate the variables. Remember, always mark your answer when you do a question as you're going through. If you found this video useful, please share, like and subscribe so we can all get great at maths. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!